I'm doing the Inducible Operon, and first we have the regulatory gene, and this is the gene that codes for an active repressor, and this active repressor fits into the operator. And then we have the promoter, and the promoter is where the RNA polymerase attaches, and this is what I'm going to use for RNA polymerase. And RNA polymerase builds the segment of mRNA, which will later be used to code for proteins. And then you have the operator, and the operator is where the repressor, the active repressor fits in. It's also known as the on-off switch. When the repressor is inside and fits, it's off, and when it cannot fit, it's on. And then after the operator, we have 3 structural genes, and these are the genes that make the proteins that break down lactose. And lactose is an inducer, which when there's an excess in inducible reactions, it binds allosterically to the repressor, changing its shape so that it cannot fit into the operator. And when it can't fit in the operator, the system is turned on and transcription begins again, and the mRNA moves down the line and eventually codes for proteins that will break down this lactose. And when the lactose is broken down, the repressor protein changes back into its original shape and fits back into the operator. And it knows when to do this by positive feedback. It knows when lactose is abundant and when lactose isn't abundant. This operon is usually turned off because there's an abundance of the lactose in its environment or within the cell. And that's the inducible operon.